So we're now going to begin answering the questions that were submitted during today's presentations. And you can still submit your questions, of course, to the chat pane in the attendee control panel. So I would now like to ask all the presenters to put their camera on, and then we will begin. Okay, let me see. I have a first question. I think it's for Hans Axel about CO2 transportation. There might also be a lot of maybe a lot of CO2 transportation by inland shipping, because in the backland where there's no storage option, they might use inland shipping to transport the CO2 to the sea to the storage site. Is there a big difference between inland shipping and this long distance sea shipping concerning the transport conditions?
Yes and no. The most obvious difference is the size of the ship that you can use on a river or a canal as opposed to open waters. So there you have a difference. But if you talk about the pressure conditions, there is no difference. You can use exactly the same conditions for inland waters as you can for open waters. What you may prefer in inland waters is to use barges where you could transport the CO2 on board a barge and then reload or whatever is needed in order to transport the CO2 further if that is required. Thank you.
Okay, thanks Hans Axel for answering this question. I have here another question about the slides from Peter Moser. You showed a figure about the battery weight for electric vehicles. So I think you showed 27 tons for a truck battery. And it has been announced that the Tesla's truck battery is announced to weigh 8 tons for a long distance version, 500-mile version. Can you elaborate a bit on that?
Yeah, for sure. We have analyzed what numbers we their performance regarding the energy volumetric energy density of the batteries we should use, and we have, I think, in the upper range used a car. For sure, there's an announcement from companies that there will be progress in the future and it will become better. But you have also seen this example with an airplane. And even if it becomes 10 times better, also this will not work. And as I want to point out, it is not we need only this technology or this is this black-white thinking that will fail to achieve the climate protection goals. There are applications where you will use batteries. It's for energy storage in the power sector, it's the same. For small capacities, use them. Yeah, if it's possible. Use for others directly hydrogen, but for some applications there is no perspective with existing technology and even with the next foreseeable steps in the future.
Okay, thank you, Peter. And here's a question. I think I will refer to Hanne. I think it's about the CO2 capture. It's about CO2 capture for cement. What are the conclusions in the ALIGN-CCUS project concerning CCUS capture on cement? Is it different from other flue gas streams? And what can we do to accelerate the development and integration of CCUS in cement?
There are some differences, and we actually are still working on the cost of capture from cement, and yes, so yeah, you have to wait until we are finished with results regarding this, and but I think yeah. This is what I would like to say now. Sorry, okay. You can have some more details tomorrow. Yeah.
Yeah, we of course Norsen was in the project, and we have done some measurements in cement to characterize the flue gas. And indeed, yeah, also cost calculation will be part of the ALIGN project and will be published after the project ends, because we're still working on that indeed. The next question is for Maxine, I think. There's a question about combining different storage sites. So it says, can we expect hub and cluster networks that combine depleted fields and saline aquifers? So combine low pressure and high pressure storage sites.
Okay, I think it will depend upon what's available to you. The options are there. This is what's being considered in the Netherlands. They have a lot of depleting fields, and they're planning to progressively use up to 4 or 5 field sites at a time. But they also have saline aquifers. One of the things that we also might do from the UK point perspective is that the saline aquifers have much larger capacities. But once you are using a large store supplying, perhaps requiring to store up to tens of millions of tons a year, once you've got your CO2 being supplied to a nearby saline aquifer, then operators might consider that they would also then sort of step out from that aquifer to reuse, rather than completely decommission their own field. They might then appraise it and consider it for extended use, additional income from acting as a storage site in their own field. So yes, I can see that that will happen, but as you can see from my 2 examples, it might happen in a different order depending upon the storage, the geological storage resources that is appropriate for a given country.
Okay, thank you, Maxine, for this answer. The next question is, I think, for Lydia, concerning work package 5. You mentioned in your presentation that hubs and clusters can reduce the risk in a full chain CCUS project. Can you elaborate a bit on in what way can we reduce the risk, and what risks are then reduced?
Yeah, so I think when we talk just generally about hubs and clusters and risk, I think that's really talking about the commercial risks of projects. And I think the benefit of a hub and cluster is that it really delinks the transport and storage aspect in terms of relying on a CO2 supply from the capture aspect. So by having numerous CO2 sources involved, it de-risks that supply aspect of, say, CO2 from one supplier has to intermittently stop. You can still rely on the other CO2 sources. So I think as a CO2 storage operator, you really benefit from a portfolio of these interlinked emitters and that ensured element of supply. And in general, just by making that system more flexible to either a stop in storage operations or supply of CO2, that, yeah, from a commercial perspective, kind of de-risks the project, and you're less reliant on one emitter and one storage aspect.
Okay, thanks, Lydia. The next question I have here is for Emma. You discussed also the public perception research, how people think about CCUS. You mentioned that the participants in that study, they had to be informed, and they read information before they provided their opinion. What information did you give the participants? And I mean, you should also bring your information, I guess, in a very neutral way. So how did you do that?
Yes, thank you for this question. Yeah, maybe to start, explain a bit. So people have little knowledge and awareness of this topic. And because of this, of course, you need to inform them in order to assess their opinion. You could also just ask them, but we know that these opinions are really unreliable and change even after a couple of minutes. So in our survey, we provided information. And the information we provided, we partly reused information from previous studies conducted in the CATO project, which were really developed with many experts, then checked with lay audiences for clarity and such. So a lot of efforts were spent there. And we do that as a basis in our project and updated the information with the help of our ALIGN partners and also external experts. And the information provided, first I'll discuss climate change, CO2 emissions, and industrial CCUS, some basic information. And then we presented a likely CCS scenario for the UK and the Netherlands and some outcomes. So the information was really pre-tested, and indeed, as Peter says, it needs to be accurate, understandable, not too much, and balanced indeed. Thank you.
Okay, thanks, Emma. I have here a question for this Peter Moser again for work package 4. Has the OME that you produced, has that actually been employed in a real car?
We have not produced OME in ALIGN-CCUS, but the car was adapted to OME, and it was analyzed how if this makes sense to produce DME, OME out of DME. But yes, the car is ready and it has the ALIGN logo, and we are waiting for some professional photos, and then we will announce it also on the webpage. But
okay, thanks, Peter.
It drives.
It drives indeed. Okay, thanks. I think this is a question for Hanne. Yeah, you did test CSR1 in 3 pilot plants. And you collected, of course, a lot of results from different durations of campaigns. Are those results also consistent for the 3 plants?
Well, as I said in my presentations, there are differences depending on the flue gases and also conditions of the pilots. But of course, we saw the tendency, for example, what I showed about the emission, that the emission of CSR1 is much higher than for MEA, for example. And also that this CSR1 solvent system, it's better, perform better when it comes to energy requirement, and it's also more stable. But as I showed, in total, the consumption is higher for CSR1. You have to replace more or have more makeup of the solvent system.
Yeah, okay, thanks, Hanne. Let's see what we have here. I think this is a question for Hans Axel concerning impurities and transportation guidelines. How does this affect the work of the operators who actually do the injection? I mean, it should keep running smoothly, of course, not too much hiccups. So will it affect the way the operators has to inject the CO2?
The main problem with the impurities, actually there are 2 main categories. One is related to HES, and that's in particular related if you should have H2S in your CO2. That has not been very much focused on in ALIGN, but that has been an issue that has been looked upon in other projects. Often you co-inject H2S together with CO2, for instance, in some projects. And in those cases, you have to take into account that H2S is poisonous. And in a very more serious way than CO2. So that's one thing. The other aspect is related to corrosion, and as we have seen in the project, and as I also referred to in my presentation, this is an important aspect for the operators to take into consideration. You have to make sure that the steel and all the equipment that you have downhole and in the injection system is not jeopardized by impurities which make corrosive phases. So you have to take that into account. Try to avoid as much as possible of the impurities as a starting point, and then also prepare maybe to be on the safe side. Use steel qualities that can withstand some concentrations levels of impurities. So that's the most important things, because the third that could be of importance is that if you have too much non-compressible gases in your CO2, it will make injection difficult. But in the circumstances that we have looked into in ALIGN, that and which we also think will be prevailing in such cases, this should not be a problem.
Okay, thanks, Hans-Axel. Let me see. I think this one is for Lydia, around the clusters. So do you see any opportunities for hubs based around, for instance, lower volume or higher quality CO2 production? For instance, CO2 from fermentation, which are more or less smaller plants, maybe a bit more isolated. Are there opportunities for those kind of hubs?
So the benefit of the cluster system is indeed that if you have different industries that are producing much smaller quantities of CO2, they can really benefit from this idea of economy of scale and attaching to a much larger transport and storage system, especially as we're moving away from R&D to commercial deployment. Rather than a point-to-point system, this is definitely a benefit of the cluster. I'm not familiar with fermentation as an industry, but if certain industries are more isolated, so for example, I know the cement industry in the UK isn't necessarily located in these ports and are more geographically isolated, that is when a hub and cluster system might not be as beneficial. If they require a really long transport line to access that infrastructure, financially it might not be as beneficial anymore. In which case, for future developments, there's definitely still a place and a potential for point-to-point systems.
Okay, thanks, Lydia. Maxine, there's a lot of talks and a lot of work in the line about CO2 specification, not only for transport, but also for storage. I mean, does different storage sites require, and different geologies requires different CO2 specifications to put into the storage site, or?
No, the constraint for the specification for the CO2 will become from the sort of transport infrastructure. Given all the sort of details that Hans-Axel and colleagues have been working on, it will be for 99.9% CO2 that does not contain any water or as little impurities as defined by the transport infrastructure. The transport infrastructure, of course, clearly in here is including the sort of wells, which we include those together, and that specification will be as appropriate and is well known for CO2, because there are gases within hydrocarbons that can be equally as caustic. And they're sort of like they are suitable. The well infrastructure is suitable for that, for acid gas is how it's referred to. But the storage reservoir itself, no, is not adversely affected by the composition of the CO2 stream.
Okay, thanks, Maxine. Here another question for Emma. Emma, you talked about the safety concerns participants had for capture, storage, and transport, and a bit more about storage, I think, than for capture. Can you elaborate a bit? What were the safety concerns? Were it emissions or leakage or health, or loss of value of property. Did you get any insight in that?
Yes, so so the safety concerns, I do have to say, as I said, people didn't, most of them had, some had never heard of CCS before and others had very little knowledge. So you provide them information. And of course, in that case, their opinions and what explains the opinions is largely based on the information you provide. So regarding these safety concerns, we provided information about the safety of onshore and offshore transport of CO2 and of CO2 storage. Based on the information of the experts, the main message was that that these risks aren't large and that there are monitoring systems in place. And if anything happens, the impacts won't be too large. But still, we could see that these safety concerns, people were still concerned about leakage and its impact. And this, in a way, and it also really affected their opinions. And this isn't a new finding. This is a finding that has been found for many different CCS applications. And what was new for us is that most of this previous research focused on power CCS and also some research on onshore storage. And you may think, well, if we store it offshore, people won't mind or won't be so concerned. But they were concerned about, for example, the impact for sea life and such.
Okay, thank you. I think this is also an interesting question. I think I will forward it to Hans Axel. It's about loading and offloading CO2 on ports and docking sites and things like that. You still remember the discussion, it was a long time ago, around the 80s, when the videos were introduced, video recorders that all had different systems and you couldn't connect one system to the other system. How about that? Is there some kind of standard being developed for offloading CO2 in ports, for instance?
There is a standardization work going on. I'm not sure exactly what all the focus areas are. There's certainly been focusing on requirements for impurity levels. When it comes to standardization of how ports should be, that is a little bit of guesswork from my side, but I would suppose that is something which international port authorities and shipping organizations would be concerned about, and that the best way to get an answer there is to see what they are focusing on. Maybe also the Northern Lights project can be helpful. I'm sorry I can't be more specific than that, but it's certainly an issue.
Yeah. Okay, Hans. So something to take up in the future, I guess. Yes. When more and more CO2 transport is happening. Let me see. I think one also rather important question about amine emissions. So I will ask that to Hanne. How did ALIGN-CCUS contribute in maybe lowering the amine emissions from capture plants?
Well, we have studied, as I said in my presentation, we have studied several means for reducing the emission. And we think that we are able to control the emission from operation, but you cannot avoid emission, but you can reduce it so that it's below the emission permit.
Okay. Yeah, thank you. Yeah, we're heading towards 1 o'clock Central European time, so I think we have to finalize this session. This questions and answer sessions are always a bit one-way street, of course. So there's less space for discussions because people might have further questions, things like that. But that is then on the program for tomorrow, because for tomorrow we have the meet the expert sessions. So for every work package, we have a time slot reserved. We can really discuss a bit more in depth, I think, also the things regarding the different work packages. And then also other experts who has done work on the specific topic will be present to contribute to the discussions. So that is on the agenda for tomorrow. So I hope to see you all again then tomorrow on the second day of this ALIGN final event. And I would like to thank everybody for attending this session of today, and also to the presenters and of course the organizers for making this possible. We didn't have any technical hiccups, so that's always very nice in this kind of online events. What I also want to mention is that there will also be a joint Act 1 project storage event on the 26th of November, where most of the ACT projects who are working on storage will have a joint event to highlight the results of those projects. And the projects that are involved there are ALIGN-CCUS, DETECT, ALIGN-C, and PRE-ACT. So what we have seen today is a lot of interesting presentations, of course, nice movies about the work that has been done in ALIGN. In the presentations, a lot of infographics were used, and we're also planning to upload these infographics on the website. So also keep an eye on the website, because there's a lot of information already on the website, but there will be more information on the website even after this event, like the infographics. And we were a bit delayed with the reporting, also a bit due to COVID. A lot of people working from home and also taking care of the kids in the first wave of the COVID-19. But there's still a lot of reports on the way, also public reports, and they will also be published on the website. So keep an eye on the website also after ALIGN-CCUS has ended. So that was it from my side. I hope to see you again tomorrow at 10 o'clock for the second day of this event. Thank you very much and have a great rest of your day.